Hello and welcome to the next episode on my tutorial series on FM sound design using the Sonicware Liven XFM. So far we've covered the basics, we've attempted to design sounds using one operator and two operator, so now we move on to designing with three operator. I would consider three operators to be the minimum number of operators for a synth to really be an FM synth in the sense that most people imagine. So hopefully we're going to design a sound that reflects that. So as before, edit mode, open a patch, init. Just like the two operator case, we have a number of different ways that we can route the sounds between the operators. In this case, I'm, rather than explaining FM synthesis again, going to jump straight in and design a sound. I'm thinking of designing a keyboard type of sound. And given that I have three operators available to me, I'm going to think of what the three elements of that sound are going to be. From my perspective, what I want is a body of the sound. I want a second envelope, which is going to adjust the timbre of that to a small degree, giving some variation as we approach the tail. And finally, I want a percussive attack sound. So this is going to be a kind of hammer sound or something along those lines. Note that I'm not specifically trying to replicate an acoustic instrument or a particular acoustic instrument, but I want to give it some of that flavor. So let's jump straight in. What I'm going to do first is make the three individual parts of the sound that are going to form the sound that I described. So first I'm going to make the body. So let's turn operator 1 up, operator 2, 3 and 4 are all down, just so I can hear it clearly. Nothing very interesting at the moment, so let's think. This is going to be similar to the Pluck type of sounds that I've described in the past. Usually if you have an attack that's too short, it sounds a little bit flat, so in the end I'm going to add a little bit of attack, but mostly this is going to be decay and release. And like a piano, I want the sounds to decay all the way down to 0, whether you hold the key or not. So I've set attack to full, decay, sustain, release all to 0. Now let's look at the times for the envelope. I want a little bit of attack, so let's listen. Decay, this is going to be the long part. Maybe even a little longer. Too long. Okay, now the release. Okay, so I think I'm happy with that. So that overall shape works. I'm thinking that the element that adjusts the timbre of the tone, now we have this basic body tone coming through, is going to be similar in shape, but it's going to be a little bit shorter. And since I want to have an interesting modulation happening, I'm going to pick a different frequency. So to do this, first I'm going to turn down operator 1, turn up operator 2, which is the operator I want to listen to. I'm going to adjust the pitch. This can go to 2. 2 is 1 octave above the fundamental. So this I'm probably going to have audible to a degree, but more importantly, this is going to offer some shape to the first sound that I made in much the same way as the plucky sound added some timbral change to the lead sound I made in the 2 operator case. So let's listen. Given that I want to pluck, I'm going to make the operator 2. Given that I want to pluck, I'm going to make the same shape of sound, but the attack and decay are probably going to look a little different. So what did I do? On operator 1, the attack was 18. I might make the attack a little sharper. On operator 1, the decay was 100. I'm picturing this is going to be shorter, so let's try setting it to 90 for now. And finally, on operator 1, the release was 55. It could be the same, maybe a fraction shorter. So let's just listen to it. Let's bring operator 1 in just to hear them together. So we can hear that operator 2 disappears before operator 1 disappears. Okay, and the final part that I'm going to make is going to be the transient sort of plucky sound at the very beginning. So I'm going to turn down the first two operators, turn up the third one. And the shape of this is going to be probably similar to the other two, but this time I'm going to probably have a more equal attack and decay. But broadly, the shape is going to look the same. So the time. Okay, and let's see, maybe I'll go for... So this is going to be the sort of hammer sound, and we're not going to hear it so much as use it to modulate the other sounds. Let's listen to the three sounds together. Let me just balance them. So listening to that, I feel like the amount of sustain that's happening on those notes, it sustains at too high a level for too long. So the way that I'm going to resolve that is using these curves. Specifically, I'm going to use the downward curve adjustment, and the downward curve, when we set it, let me just demonstrate it. Let me only listen to operator 1. The downward curve, when we set it negatively, it keeps the sound louder for much longer. When I set it positively, sound drops in volume very quickly. So let's... So I think to me that makes a little more sense, and I can imagine that we want that drop to happen more aggressively with operator 2. So with operator 2, I'm just going to turn it up a little higher, and let's bring them both in. So notice that so far no frequency modulation has happened whatsoever. All I've done is mix together the three different sounds that we have here. Maybe for the... So I did not mean to do that. I just adjusted the detune by accident. Page 2, operator 3. What I'm going to do here is I'm going to make the attack of operator 3 last a little longer, and then the decay lasts a little shorter. This is just a little accent that I'm adding, really. Let me listen to it. Sounds fine. So now I'm going to balance the volumes. So notice that so far no FM synthesis is done here. These are just sine waves playing against each other, and yet we still have a relatively interesting timbre. But what we want to do is add a little more flavor to the sound, add a little more bite. And since I know we're going to use velocity sensitivity here, what I'm going to do is turn the velocity to maximum, because when we enable velocity sensitivity, it's going to decrease the volumes from this point. So what I want to do is design the sound at its brightest, and then I will make it less bright going forwards. So the first element of this is going to be just adjusting the timbres of the different parts. Then I'm going to adjust the modulation amounts between them. So let's switch to timbre adjustment. I'm going to do operator 1 first, bring it to 0. So operator 1 is not going to be adjusting the brightness of the sound here, in that I'm going to use operator 2 and 3 as modulators. Operator 1 is going to be a carrier. I'm actually probably going to bring both of these out to the mixer to a degree. So this timbre is as any brightness I get here is not going to go away as the velocity decreases. So I think that's good. Let's listen to operator 2. Remember that we're going to start modulating across these. This is feedback I'm adjusting. So I've made the first one a little square wave. The second one is a little saw wave. Okay, so now you could say this is FM synthesis because we are using feedback to adjust the timbres. But we don't actually have any modulation going between the operators. So now I'm going to make some of these connections. I'm going to go to operator 1, page 1, and I'm going to make it get modulated by operator 2. Okay, remember this is maximum velocity, so this will be as bright as it goes. Let's modulate it by operator 3. Okay, I think that sounds pretty good. When we have a chain of operators modulating each other, the more complex the sound doing the modulation, the more complex the modulation will be. So what this means is if I have a stack of 3 operators all modulating each other, that will give more complexity than simply one modulator modulating the next. So what I'm going to do is operator 2, I'm going to modulate it by operator 3 to an extent. Okay, I think that's sounding reasonable. Now I'm going to try and introduce some velocity sensitivity, and I'm going to think about how I want that velocity sensitivity to work. From my perspective, I think the bass sound, that initial pitch that I made, I don't want it to be hugely velocity sensitive. I don't want it to very aggressively decrease in volume. So what I'm going to do is set that to, let's say, a level of 30. So at the moment, the timbre is shifting because the other operators are not changing with the velocity. Operator 2, I want operator 2 to be a little bit more sensitive to the velocity, let's say 45, and operator 3 probably a lot more sensitive to the velocity, so let's say 75. Maybe that's a bit aggressive. Let's try 65. That's sounding reasonable. The next thing I want to think about is time scaling. So time scaling indicates how much shorter these tones become as their pitch increases. Given that I'm modeling a keyboard, it's probably something that is acoustic or electroacoustic, so I would like that to happen. So let's listen in the treble. Very, very long. So I think what I want to happen is the hammer noise, I'm imagining, won't get much shorter with time, so I'm going to have that a relatively low scaling number. I think the sound which is adjusting the timbre of the bass sound is going to be a little bit more scaled, and then the actual bass sound is going to scale the most. Could be even shorter than that, I think. So let's try time scaling. Let's put this one up to 65, this one up to 45, this one can be 25. So let's listen to the length of the sound. Okay, I think that sounds good. So what we're going to do now is think about the relative volumes of these sounds as we go up and down the registers. So my thinking is that in the bass, sounds pretty cool actually, but what I might like to do is make a little bit more of the modulation tone and a little bit less of the fundamental tone. So hopefully you can hear a little bit more of that timbral change, that sort of punch and that transient. So let's go up into the treble. So I think in the treble there is enough brightness that comes directly from the bass tone because the pitch is high. So what I'm probably going to do is turn down the hammer tone quite a lot. Turn down this other tone. Okay, so I think now we've shaped something which is sounding like a keyboard sound. Again, we don't have velocity sensitivity on this keyboard, but if I modulate the velocity a little, you can hear that we're not only changing the volume, but we're changing the timbre of the sound. I think the only other thing that I'd like to do is to add a little bit more character to this sound. I'd like to detune the operators a little bit. So, very straightforwardly, either with the detune function here or the detune knob here. So I'm going to use the detune knob here. So let me just adjust it and listen. So I just want to be subtle, really. Okay, now I'm going to go through and I'm going to revisit the feedback amounts, and I'm going to revisit the relevant volume, the relative volumes of the operators. So first, let's look at the feedback amounts. Operator 1 has feedback -11. Let's listen to it. Let's try adjusting it. I think that's probably acceptable. Operator 2, feedback. Okay, so this is a maximum velocity. Operator 3, feedback. Okay, I think that sounds pretty good. So let's now revisit the volumes. What I'm going to do here is turn them all down, and I'm going to bring them up and just listen and see how I like the sounds. This is maximum velocity. So just the subtle hammer noise. Okay, so I think what we have is something that's relatively playable. Let's try in the bass. Quite interesting there, a little bit higher up. Works reasonably, and in the middle register. So I think we've gone through and we've defined our algorithm on the fly. That's to say, all of the operators are outputting to the mixer, but predominantly it's operator 1 with a little less operator 2 and a little less operator 3. And the modulations, they all have some feedback. Operator 1 is modulated by both operator 2 and 3. Operator 2 is modulated by operator 3. And so we have some nice soft tones when we're playing at low velocity. We have some nice bright tones when we're playing at high velocity. Obviously we could go through and we could tweak the envelope times, we could tweak the ratios and fine-tune the sound a little bit. But for now, I think I'm happy with this. So I'm going to sign off for today and hope you enjoyed the 3 operator tutorial, and next time we'll come back and make another sound using all 4 operators of the synthesizer. Thank you for watching. Bye bye.